Hello everyone, welcome to the first lecture of Altium Designer for the SFU Robot Soccer Club. The goal of these lectures for Altium Designer software is to learn how to use Altium Designer, which is an industry level software to design circuits and PCBs. And it's a software that we use in our club to design our circuitry and uh, manufacture our PCBs. So the goal of this presentations are not to go in a lot of details with how Altium works and every single feature that it has. Gladly, Altium Designer is a really good software and it has a lot of documentation on the Altium Designer software itself, as well as just internet, like a lot of YouTube videos and a lot of other videos from other sources that explain how things exactly work. If you have any specific questions, the main goal of this is to basically learn the general concept of what is Altium Designer, why we use it, and how to make a basic project and do basic tasks with Altium Designer. So first I'm gonna open an example from one of the circuits that was designed by the club. This is one of the motor drivers. I'm just gonna open it right now. Okay, as you can see, I have opened the project, and so the first thing to know is a project in Altium Designer has two main components, the schematic and the PCB. The schematic, as you can see here, is a symbol and representation of all the components on the board that we have designed, with as well as like showing how they are connected to each other. So we have all of these components that you can see in yellow, or some other shapes like these diodes or capacitors. Basically, the schematic lets us to put these parts here in the schematic, and using wires and net names connect each of them together to be able to like design the circuit. And after finishing the circuit design in the schematic, we are going to be able to go to PCB and design the PCB for that circuit. And this is basically what is going to be manufactured and seen after being produced and soldering all the components on it. So the goal is basically learn how to go from the schematic, designing a specific component that might not be in the schematic, and finding a way to basically able to make this PCB, import all of those parts into the PCB and make it. So I'm just going to close this project for now. To begin with, first we have to make a new project. To make a new project, we can just simply go to File, New, Project. And this will window open up, and then we can basically define our project. We can use the local projects. We are not going to use version control or Altium 365. Those are other options for storage. That is a bit more complicated. But we are just going to keep the local projects, and we are going to choose a project name. I'm just going to call it first, and we can choose where to store the project. I'm just going to store it here, and then create the project. And after a bit, the project is created. Right now it's called first.project.pcb. Just one thing to mention, there are many other options in this, like many other new options you can make, like schematics and active bombs and cam files and libraries and stuff. We don't really do any of this. The only thing that we are going to learn in the future lectures is how to make our own components in our own libraries. Otherwise, rest of it, we are not going to learn. After creating a project, we have to add a schematic to it and add a PCB. So I'm just gonna, to do so, you can just right click on the project name, add new to project and add schematic. And boom, you have a new schematic. And then after that, you can do the same thing, right click on the project, add new to project, and then click PCB, and you have a PCB. After adding the schematic and the PCB to your project, you have to go to File, Save All, and choose a name for the files. I'm going to choose first, save it, that's PCB saved, and choose a name for the schematic as well, save. And now both of them are saved. The way you know it's saved, these file colors should be white. After making the schematic and the PCB, we have to insert components into our design. Now, there are two ways to do this. The first way is to go to this top bar, click Place Parts, and you have this components list here. I'm going to just bring it here so it's more visible. And just give me a second. Okay. So in this way, we are able to add all the parts that we want to our design. Now, this list most likely doesn't include any of the parts that we have. So we are going to learn in future lectures how to use the library designed by the members of the club, and the library, how to make a component in a new library, so you can modify and add components to the list of the parts that you have. But for now, for this first lecture, to just show the concept on how things work, I'm going to add, make a general circuit. The circuit that I'm going to make for this lecture specifically is called an RC low pass filter. So what we need for a low pass filter is one resistor and one capacitor for a passive low pass filter. What I'm going to do is find the resistors and then choose them. I'm going to choose this one, and as you can see, I was able to bring in one resistor here, and I'm going to add a capacitor. If you just search up here, you can either search here just like cap and then it brings you, or you can just scroll through the list and find it. To do so, I'm just gonna add a capacitor, not that one necessarily, but maybe this one. Okay. So now we are able to import a resistor and a capacitor to our design. Now, basically we want to connect these two and wire them up together. So I'm just gonna use some general concepts. First things first, Altium has many details on how things can be done. There are many ways to do things. You can learn the macros for every single move. Instead of pressing the place part here and opening this list, you can just double press P, and that brings you to this list still. And many other macros that you can learn. To learn the macros for Altium, if you look at the list names, each of them have an underscore under the letter that activates that list. For example, if I want to go to tools, I can either just press tools and then annotation and then annotate schematic quietly, which we will get to what that means. Or I can just press T and then A and then U, which is all the underscore letters for those actions. So if you want to learn the macros, that's a good way to learn them. Another thing to mention in Altium, if you drag from right to left, it doesn't matter if it's up to down or down to up. As long as it's right to left, you can see the borders of the selection is green. Green means if part of the component that you're selecting is in the area of the selection, the part will be selected. Now, if you go from left to right, again, it doesn't matter if it's down to up or up to down, it's a blue border. And when the border is blue, it means for selecting the component, the entire component has to be inside of the box. Now, I can show you that. If I select only half of the capacitor, it's not going to be selected, but I have to put all of it in the box for it to work. But if I go from right to left, I don't have to put the whole thing in the box. Now you might ask why this can be useful. Sometimes in a design, in a bigger design, you want to select only this component. Let's say these are two like really close to each other like this, and then you only want to select the resistor and you don't want to select the capacitor. Now, if you want to only select the resistor, you would have to go from left to right like that and don't cover the capacitor. In that way, only the resistor is selected, just like this, as you can see. And if I do the same thing, but from right to left, as you can see, both components will be selected. So sometimes you don't need to select the capacitor and you go from left to right. Sometimes you need to select both, you just cover both of them. Just a minor detail. To rotate the components, what you should be able to do is you can select and hold the component. You can move it around like that. And by pressing space, you can rotate the components 90 degrees counterclockwise. So yeah, I'm just gonna rotate the capacitor like this and put it here. Now, for connecting the, let me trace back here. So the components that we chose, the capacitor, resistor, and diodes, and everything else that you see in this list down here, it's chosen from the miscellaneous devices library, which is a default library that Altium comes with included. You can choose that, but there's no connectors here. Connectors are basically the components that we can use on our boards to connect wires and stuff to it, so you can have external connection to the board. To change the library, you can simply click the library here, go to miscellaneous miscellaneous connectors library, and these are all the connectors that Altium lets you use. For purpose of this lecture, I'm just going to use the header 2. And again, press space to rotate it like this, and then use another one on this side. And now I imported 2 connectors to this design. Now we want to connect all of these together to make the circuit that we want. A quick point here is I keep saying the circuit that we want, and you might wonder how we are going to design circuits. There are 2 ways. You either learn the circuits in the classes, or what we do usually in the club is search up other teams' works or search online and see what we want to do with the circuit, and use reference designs from other teams and other organizations and to use those. Or again, as I said, you can learn them in classes as well eventually, especially if you're in electronics engineering program. So what we can do to connect these, we can come up here to this bar up here and right click here, and you see you have some options. We are not going to talk about bus and bus entry for now, but we want to place a wire. We want to place a wire that connects these 2 components together. How I'm going to do that, I'm just going to press wire and come to the end of to the right side of the resistor. As you can see, when I select the end bit of the resistor, it turns to a red cross, and now I can draw my wire. I'm going to connect it to the top of the capacitor. I'm going to connect this to here and that, and then I'm just going to connect all of these together like that. Now, all of the components that we have in this circuit is connected together, and yeah, that's basically how you connect the components together. Another method of connecting components together in general is net labels right here. So for the purpose of demonstrating on how this works, I'm just going to quickly reverse the changes. So just give me a second. Yes, okay. I'm going to reverse the changes and add these. Okay. So now let's say, for example, I want to connect this wire from here to here and here to here. Now, this is obviously easy to do, like just what we just did, but let's say there's a bunch of other stuff in here that we don't want to have a wire just crisscrossing everywhere. What we can do, right click on where the wire is, plus a net label. Now, for a net label to work, I'm just going to put one here and one here. What I personally like to do is to have the net labels to sit on the wire. So I would just double click on the net label, the properties of the net label will open. I'm going to change it to whatever name that I want. I'm just going to call it plus, and then change it so it's on this side of the wire. By pressing this arrow, it just changes the position. And I'm going to call this negative, like that. And after doing so, let's say I want to connect this wire to this wire up here. I'm just going to click on this, left click once, copy it, paste it, and connect it to this side. Or what I can do, I can put a net label here and call it same thing as I called it the other side, negative in this case. One thing, key thing to remember regarding the names is they have to be exactly identical to each other. So if this is called negative, this has to be exactly called the same. Even the capitalization of the letters matter. I'm just gonna fix this one, the positioning, and yeah, now this wire is connected to this wire, and this wire is connected to this wire, and now you have connections. But because this doesn't make sense in this scenario, I'm just gonna delete it. I was just going to show you how net labels work. Let me just reverse every action. Okay. So as I showed in this list, there's also bus, something called bus. We are not going to talk about it in this lecture, but essentially bus is a few wires bundled together. I can just draw a bus probably here to here. As you can see, the wire is thicker. All it means is just, it's a few wires. It's not just one wire. That's all it means, but we can get to that in future lectures. Just gonna use the wire for now to connect these together. Now, with designing a schematic and PCB, with PCB you have to follow some specific rules regarding how you can put the wires and stuff so the circuit actually works. With regards to a schematic, as long as the connections are correct, the schematic will be functional. But a good practice is to have a neat and tidy design. To do that, I'm just going to try to make this a bit look cleaner looking by moving this around a bit. And let me just give me a second. I'm just trying to make this look a bit cleaner. That's all. And I'm going to typically, I personally don't like to have the wire that is crossing perpendicular to the component to directly connect to the end bit of the component. That's why I have this extra tiny bit of wire extending out of it. Otherwise, everything looks fine. So you can see that the resistor here has a 1 kilo ohm value and the capacitor here has a 100 picofarad value. We will get to this in the next lecture when we are trying to design our own components. But essentially, when we are designing our own components, we want to design every different value of the resistor ourselves, every different capacitor ourselves. You'll see in the next lecture what I mean by that. We have to design every single component, even if they are the same component with the same shape and size. but different values, we have to redesign every single one and change the values for it. So it's correct. The purpose of the values to be correct for in the design is for us to have an easier time to generate a bill of material, as well as that it's for readability of the circuit. As I said, the schematic has to be clean, nice and tidy and understandable for anyone. So you have to have correct values everywhere to make sure everything looks fine. To be able to change the properties of any of these on the go, you can just simply come and change the comment or the designator, which we are going to talk about in this bit, and stuff like that. If you are willing to change the names and stuff. So now the next thing that I want to talk about is reference designators. You can see that for this one, the reference designator is called P question mark. For this one, it's called R question mark A, C question mark, and P question mark. We call those reference designator. Now, why it's question mark? Because just that's the default value that Altium uses to show the component it's new and it doesn't have a name. For a schematic to work and for Altium to be able to understand and generate the parts correctly, and for manufacturer to be able to pick and place the parts in the correct spots, every single component has to have its own unique identifier or unique reference designator. So as you can see, Altium right now, it has this red bar here and red bar here. The reason that those two are there is because this component here is called P question mark, and this component here is also called P question mark. And Altium doesn't like that. Altium doesn't want you to have the same name for two different components. It's like the fingerprint of that component. It has to be unique and specified for that component. Usually we use R for resistor, C for capacitor. The connector names, it can change to anything. For example, I can just change to input, and I can change the other one to output. But the other ones, we have to also change. I can change to R1 and C1, meaning the first capacitor and the first resistor. Now, this is possible to do one by one when the design is really small like this, but when the design gets more complicated, we want to be able to do this automatically. So I'm just going to add a bunch of other resistors here. I'm not going to connect them to anywhere, just showing that. Let me just change this one with this. Okay, I like that better. I'm going to, let's say we have resistors and I don't know, we have like a couple of more capacitors. Yeah, we have capacitors and we have like diodes. We have all of these components added. And as you can see, Altium doesn't like the fact that all of these have the same name, because they shouldn't have the same name. Every component on a schematic design has to have its own unique name. Or unique reference designator. They can have the same values, as you can see, 100 picofarad, 1 kilo ohm, a diode IN 4005, that's just the model number for the diode, but they cannot have the same reference designator. Now, as I said, you can just go one by one and change them by double clicking and going to properties of the component, but we don't want to do that if the design is big. To do so, you're just going to go to Tools, Annotation, and annotate schematics quietly, and it's telling you that it's going to change the name of 8 components. As you can see, we have 8 components here that they have similar names. That Altium doesn't like that, so it's going to change all of them. Press yes, and boom, you have proper resistor naming. Each resistor has its own unique name, each capacitor has its own unique name, and each diode has its own unique name. Now, as you noticed, I pressed annotate schematics quietly, which means it doesn't ask you for any properties or any characteristics of how it wants you to annotate the components. But if you want to define how the components are annotated, you can do you can go to the annotation, annotate schematics, and ignoring all of the other stuff that is going on here, which can give you some more options on how to annotate stuff more precisely. What I want to mainly talk about is the order of processing the annotation. As you can see right now, it goes across, then down. You can change this to across, then up, down, then across, or up, then across. So you can just change these. If I change that to up, then down, and then press, I believe yes, or accept, you just press update change list and then accept changes. And then you say execute changes and boom, boom, boom. As you can see, now it's up and across. So as you can see, this one is to the left of this one, so it's annotated first, and then this one is to the left of this one, so it's just annotated like that. So you can just choose the annotation properties on how you want it to be annotated. Or you can just reset the entire designators, which resets the entire sheet. We don't want that. So I'm just going to delete these extra components. Cool. So now we have basically made ourselves a circuit that has basically the connections that we want and everything. Now we learned about wires. There are something called harnesses, which we are going to learn in, again, future lectures. There are sheets and sheet symbols that we are going to talk about what are sheets and how we can make a multi-schematic design. Ideally, you want to have a multi-schematic design for bigger designs so it's easier to read. And there are ports and off-sheet connectors. So these are basically the connections that you have that shows the connection of one component in one schematic design to another schematic file on your design. So we are going to talk about all of these later, or the parameters and stuff like that, the characteristics. The other thing that I was going to talk about is just you can put a text file or a text frame. So for example, you want to set some comments here, you just import here and then write your text, whatever you want to write here. And that basically, that's how you import text. The one thing that I want to talk about in this lecture is the power identifiers. So let's say in a circuit you have ground, you have 5 volt, you have 12 volt, you have the power lines, and you want to call them properly. So one way to do that is right click here and you see a bunch of options. We usually don't really use the options at the bottom. And to make a power port, essentially, as Altium calls it, we are going to start with a ground power port. Let's say I want to ground this line here. I want to ground this wire and define that the name of this wire is ground, and this is the ground side of the circuit. So what I'm going to do, I'm just going to bring the ground here and connect it to the design, or we can connect it here. Now that's basically telling Altium this is the ground name, or like the wire name is ground. You can call it anything else that you want, or I can place a VCC up top. Now this doesn't really make sense. I'm just adding these components to show how it works. We usually wouldn't do this. But yeah, VCC basically is telling that this wire here from here to here is called VCC. Now I don't know if you have taken ENSE 220 in SFU or not yet, but wherever you put a net name or a power port, the entire node name will change to that name. So in this case, this node, which is, and all of these wires here, are going to change their name to VCC, and all of this node, which is all this wire from here to here and here, is called ground now. So that's how you add power ports. Now sometimes we want to add a specific power ports. We can just change the name to something like 3v3, and that basically says this is a 3.3 volt a line, or 5 volt line, or 12 volt line. And if you wanted to have a plus or minus, you can just add a plus here, or you can just add a minus here. Basically, by double clicking, you can just go to the properties and change all of these components. And that's how you design a schematic. So I'm going to show you again the project that I had open for the auxiliary driver in our robots. It's just processing right now, waiting for it to open. Maybe it didn't open. Okay, now it's open. I'm going to now show you all of the components that I talked about. So now you see capacitors with different values, 100 nanofarad, 10 microfarad, 10 microfarad, these diodes with different values, this capacitor, this component with this big component with its own name and identifiers, U1, this connector called J1, usually connectors are called J with J identifiers. This IC here is called U3 with like the resistors and capacitors, everything attached to it, and U2 and all of that kind of stuff. So as you can see, these are the power ports called ground, 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 and these are the other power ports, the higher up power ports, like 5 volts and 12 volts and stuff. In this case, it's just 5 volt, and it's 5 volt also here and 5 volt here. This is another power port. As you can see, it has this symbol that shows this is a power. This is a power that is not ground. And another nitty-tidy thing to keep in mind, we usually try to keep the designs clean so it's readable. We want the grounds to be in the same line, and always the grounds are going to be facing bottom, and the powers are going to face up. So like you can see that the ground is facing down and the 5 volt is facing up and all that. So those are the power ports. And now we have a bunch of net names that we are going to talk about. For example, these net names, this is a net name that it's here. It's called aux M1, aux M2, aux M3. So what that means is these are wires that are connecting these diodes and components together, but this wire here is called aux M1. Now if you want to connect the aux M1 to this other component, we can just also call this aux M1. Now this group of wires here and these wires here, all of them are connected to this wire here because they have the exact same name. That's how we connect components, as I mentioned, that are really far, and we don't want to draw a big wire from here to here to here. That is not ideal. So those are the things to keep in mind and how a proper finalized design looks like. Now, to navigate through the schematic, I forgot to mention this, by scrolling up and down on your mouse, you are just going to move the page up and down as you'd expect. But if you hold the shift and scroll, you're going to scroll left to right. It's just the same motion, but you have to keep holding shift so it goes from left to right. And if you hold control, you can zoom in and out. So that's how I'm navigating through the document. This is scroll up and down. This is shift scroll up and down. And this is control scroll up and down. So yeah, that's basically how a design looks like. And you can see now the components, the file looks red, like it's instead of white here. That means it's just not saved. Yeah, so that's basically it for the first lecture. I hope that you learned a bit here.